right, let's talk about a quiet revolution that's totally changing how we build the future. We're talking about the strongest, lightest materials you can imagine. It's a story about taking what was basically a high-stakes guessing game and turning it into a precise science, all by giving our factories the power to see inside a black box. Okay, let's get into it. So what you're looking at here is an autoclave. Think of it like a giant industrial-strength pressure cooker. Inside, we forge critical parts for things like airplanes and massive wind turbines under insane heat and pressure. Now, these parts are basically modern miracles of science, but making them is, well, it's incredibly tricky. Because once you shut that door, you are completely flying blind. And that really gets to the heart of the problem, what we're calling the Composite Conundrum. You know, for decades, one of the most advanced manufacturing processes on the planet has happened, for all intents and purposes, in the dark, sealed up inside a pressurized steel box. To really get what's at stake here, you gotta understand the process itself, curing. It's this super complex chemical reaction that takes a liquid resin and transforms it into a rock-solid material. It's less like baking a cake and a lot more like high-stakes alchemy, where one tiny mistake can ruin the whole thing. Check this out. The material goes on this incredible journey. At first, the resin is a liquid, flowing all around those carbon fibers. Then, bam, it hits this point of no return called gelation. It becomes a gel. It can't flow anymore. And finally, through vitrification, it just locks into its final hard, glassy state. Getting every single one of these stages just right, well, that's the whole ballgame. So here's the bottom line. With no window into that autoclave, manufacturers have always had to rely on experience and, let's be honest, a good bit of guesswork. They come up with a recipe, a set temperature and pressure cycle, and just cross their fingers, hoping it works for every single part inside. And wow, this image just says it all, doesn't it? These are scans of a part while it's curing. On the left, you see a solid, strong part forming. But look at the right. See all those light areas? That's a nasty defect called porosity. Every one of those little voids is a weak spot, a potential point of failure that could compromise the safety of the final product. And here's the really scary part. The most dangerous defects, you can't even see them. The FAA itself points out that what you see on the surface tells you almost nothing about the hidden damage lurking inside. A part can look absolutely perfect on the outside, but be a ticking time bomb. So for years, the million-dollar question has been, how do we turn on the lights inside that black box? Well, the answer is finally here, and it comes in the form of amazing sensor technologies that can act as our eyes and ears, even in the extreme environment of an autoclave. So, how's it work? First up, we give the factory eyes. I mean, literally. This system from NASA actually puts an ultrasonic scanner inside the autoclave. It pings sound waves through the part as it's curing, which lets engineers actually see defects like that porosity forming in real time. It's incredible. Then, get this, we give the part itself a nervous system. Engineers can now embed these hair-thin fiber-optic sensors right into the composite material. As the part heats up, shrinks, and gets solid, these tiny sensors are measuring the internal stress and temperature with unbelievable precision. You know, it's not a one-size-fits-all solution. Each sensor has its superpower. The ultrasonic systems, they're fantastic for scanning big areas to hunt down those voids. But the fiber optics, they're perfect for getting super precise temperature and stress readings from critical spots inside the part itself. Plus, they're totally immune to any electrical noise. Okay, so seeing a problem as it's happening is amazing, but what if you could predict it and stop it before it even starts? The real game changer isn't just watching the cure. It's using that data to actively control it with artificial intelligence. And this is where things get straight up sci-fi. This diagram shows an AI framework developed by Boeing and the University of Washington that basically acts as a master chef for the autoclave. It takes all that live data from the sensors, figures out exactly what's going on, and then adjusts the recipe, the heat and pressure, on the fly. So how fast can this AI think? Just to understand what's currently happening inside the part, it runs 300 complete physics-based simulations every single second. But that's nothing. To figure out the perfect fix for a problem, the AI can test over 35,000 different what-if scenarios, potential tweaks to the recipe, every second. It's just mind-boggling, ensuring it finds the absolute best way to make a perfect part. And the results? They speak for themselves. Look at the chart on the left. That was the original plan. Those parts were headed for disaster, on track to get way too hot. But on the right, the AI steps in, rewrites the script in real time, and creates a new heating plan that keeps every single part perfectly in that safe zone. I mean, the hard data is just undeniable. Take a look at part 3. It was projected to hit a scorching 213.8 degrees Celsius. That would have ruined it. The AI controller saw that coming, adjusted the cycle, and capped the temperature at a perfect 181.1 degrees. It literally solved a multi-million-dollar problem before it even happened. But look, this is about so much more than just making one perfect part. What we're really seeing here is the dawn of an entirely new era of manufacturing. This is the smart factory future, and it's happening right now. So why should you care about all this? Well, it means stronger, safer planes and more efficient wind turbines for all of us. It means we stop scrapping multi-million-dollar parts, which is a huge reduction in industrial waste. It lets us innovate faster and, frankly, creates a much leaner, greener way to build the world of tomorrow. You know, this completely changes our relationship with how we make things. We're not just giving a machine instructions and hoping for the best anymore. We're having a real-time conversation with the materials themselves. So, as our factories learn to see, to think, and to adapt, it really leaves us with one final, very exciting question.